Good afternoon, this is Busy. As you probably know from my posts on the Energetic Forum, I am working on a Watson machine. What you're going to see here today is not a working Watson machine. What you're seeing here is the results of my work with alternators that will be used in a Watson machine. I posted my results on the Watson machine thread a couple days ago. I think some people were skeptical, so they asked me to actually show the alternator working, and that's what this is all about. Again, this is not a working Watson machine as of yet. I hope that someday soon, very soon, it will be, but this is not it today. This is just to show the alternator. Over here is a simple 6-coil alternator with some of the improvements that I've made in a Delta configuration. The disc has the magnets on it. This right here is a homemade bridge rectifier. This is the kind I've used on my windmills in the past. I like this a lot better than the store-bought rectifiers because it seems that I don't lose any current when I use these homemade versions as opposed to the ones you get from Radio Shack or wherever. This is a simple capacitor. I have across both the positive and negative poles of the rectifier. That's to smooth out the voltage. Over here, I have 3 meters. This meter here is going to measure the voltage going into the motor. Over here to the left, you'll see a battery. This is what I'm going to be using to charge or to run the motor itself. You really can't see the motor. It's underneath the table here, but these 2 wires here go underneath it and power the motor. And that's this multimeter here, which is going to be on voltage. This meter right next to it is voltage, and we'll be measuring what is coming out of the alternator itself and through the rectifier. The meter right next to it is an amp meter, which I'll be using to check the amps coming out of the rectifier and the alternator. You can't really see it, but behind the amp meter I have a small little motor which I'm using for my load. So when we test the amps, it'll be under load. Now I'm going to adjust this a little bit so you can see get a picture of the alternator on the right and the meters on the left. Now I'm going to turn this on. We're just going to check the voltage coming straight out of the rectifier. As you can see, we had 12.2 volts going in, and then coming out we had 40.2 volts going out. What I'm going to do is come over here. I'm going to short out this small capacitor. Maybe. Now what I'm going to do is I'm going to hook up the small motor in the back so you can see how this works with under load. There we go. Now this is very hard to see because it's not digital, but you'll see that it does rise. You can see that there's a lot more drag on the motor when you do have a load coming directly out of the alternator. We have 11.6 going in and approximately 9 volts coming out with 3 amps of power, and this is under load. Now, the whole idea of a Watson machine is that it will power a motor through a battery. So what I'm going to do then is I'm going to hook this up right to a battery to show you what power is going in. And what I have here is just a single diode to make sure the electricity doesn't flow out and the voltage just continues in to the battery itself. Again, just watch these 2 meters here. This is power going into the motor, and this is coming out of the alternator. So again, you can see we had 11.7 volts going from the battery into the motor, and we had 13.6 volts coming out of the alternator and being fed back into the battery. Now, granted, doesn't show how many amps went in it at all, but it does show that there was at least enough voltage going in where it can make a little bit of a difference. Now, what I'm going to do is put a capacitor in series between the alternator and the diode going into the battery, and so basically you're charging the battery through this capacitor as well. As you can see, there was a significant increase in voltage going back into the battery just by putting a capacitor in series. Now, I use the larger ones simply because I know that I'm producing a lot of voltage out of here, and I don't want to risk destroying a smaller capacitor, but I'm sure any capacitor will do. But my main point here is just to show the amount of voltage going into the motor versus the amount of voltage coming out of the alternator on the same shaft as the motor. If you have any other questions, you feel free to ask me on the open post, or if you want to just drop me a private message through Energetic Forum, you're more than welcome to do that too.